Hi, for today's warm-up, I'd like to have you take a look at the graph on your screen and determine if each ordered pair is a solution or not. All right, let's check and see how you did with this. Just a little review from yesterday's lesson. So we know that solutions to linear inequalities like this on a graph fall inside that shaded area. Okay, that shaded area in red. So we can see that the ordered pair down here at -5, -3 is in fact a solution because it's in the shaded area. It's actually one of the many infinite number of solutions that make up the shaded area. Then we have an ordered pair that's not in the shaded area. So that one is not a solution. And then we have this last one that is at 0, 2 that happens to be directly on the boundary line. Now, as we saw in the last lesson, sometimes an ordered pair on the boundary line is a solution. Sometimes it is not a solution. It depends on what type of line we're dealing with. In this case, we have a solid line, and anytime we have a solid boundary line, points along that line are also solutions. So 0, 2 is a solution here. We're going to continue to build off of that today, but what we're going to do is we are going to take the time to graph the linear inequality to make it look like this using Desmos. So I'm going to show you how to use Desmos, and then you'll get to practice on a few problems. So here's how we graph linear inequalities using Desmos. Okay, we've used the format before. We know it's at desmos.com, and we click the graphing calculator button. But once you get in there, we want to start by doing number one. Type the linear inequality into the Desmos calculator, okay, in the editing area. Now, for some of the inequality symbols, your keyboard has a less than symbol and your keyboard has a greater than symbol, but your keyboard does not have less than or equal to as a symbol. So to make the less than or equal to symbol, you would type the equal sign directly after pressing the less than symbol, and that will automatically make it less than or equal to in Desmos. You would do the same thing for greater than or equal to. Just make sure you do the greater than symbol first, and then the equal sign directly after that. Sometimes when you're entering your equations, you'll need to enter in a fraction for the slope, for example. So just make sure to use the slash for fractions. Desmos will automatically make it look like a fraction. And when you're typing your x after it, if it is the slope, make sure that your x is not in the denominator of the fraction. So make sure you either press the right arrow key or click at the end to move the little blinking cursor out of the denominator. So here's our first example. We're going to graph 2x minus 5y is greater than or equal to 8. And then we're going to use the graph to answer the question, which of these ordered pairs are solutions? So one way we could have done this without graphing is to take each of these ordered pairs, substitute the x and the y values into the inequality, and check to see if it's true or not, just like we did in the day one lesson. But we're going to do this with a little bit more speed today since we are checking multiple ordered pairs for the same inequality. All right, let me open up, there we go, the graphing calculator. And there we go. I want to type in exactly what I see in my inequality. So 2x minus 5y is the left-hand side. And then I want the greater than or equal to symbol. So I start by typing greater than, and then I press equal. And it will automatically add the little line underneath the inequality. And then I finish it off with an 8. Now, another way to get that symbol in this keypad, there are the 4 inequality symbols right here. So if you didn't want to just type it on your keyboard, you could always open up the on-screen keypad and do it that way. All right, now we were supposed to check and see if these ordered pairs are solutions or not. So one way you could do that is to just look at the coordinates -3, 1 and plot that point visually. And we can see it looks like it's going to be right about where my mouse is pointing, which would not be a solution. Now I want to show you another way that you can do this, and it actually makes it stand out a little bit better. So if you click Add Item and then Add a Table, we can enter these 3 data points into a table. And since it's in a table, Desmos is going to add it to our graph, which is kind of neat. So I'm going to do -3, 1. Notice how it adds it right here. Oh, you know what? I was looking down here at -3, -1. Good thing we checked because I was plotting it wrong in my head. 4, 0, and last is -1, -5. All right, so there's my 3 ordered pairs. You can always click on the dot, and as long as you don't click off of it, it'll stay up there. So I'm just clicking each one. So we can see specifically which ones correspond with those coordinates. All right, so let's see, which of these are solutions? Well, it's a solution if it's in the shaded area. So -1, -5 is definitely a solution. So my third one here is a solution. 4, 0 looks like it's right on the boundary line. And because it's a solid boundary line this time, then yes, it is a solution also. So 4, 0 is a solution, -1, -5 is a solution, but -3, 1 is not a solution because it's not on the shaded side. All right, so let me just record that here. So we had not a solution for the first one. The second one was a solution because it was on a solid boundary line. And then the third one is a solution because it was in the shaded area. All right. What I'd like you to do is pause the video and take a minute to graph number 2, and then check to see which of these ordered pairs are solutions. So please pause the video, try this on your own, and we'll see how you did. All right, so here we have our inequality for y is less than -3/4 x plus 2. I also added the table of values using the ordered pairs 2, 4, -2, -1, and -4, 5. I clicked on those 3 purple dots so that I could see the labels for each one. And now I can identify which of these ordered pairs are solutions. Well, I can see very clearly that the first ordered pair is not a solution because it's not on the shaded side. So 2, 4, not a solution. I can also see very clearly that -2, -1 is a solution because it is on the shaded side. The one that I really have to think about is this one that's on the boundary line. -4, 5 is on a dashed boundary line. And as we saw in the last problem, the difference between a solid line and a dashed line is that a solid line has solutions on it. A dashed line does not have solutions on it. So -4, 5 is not a solution. So the first one is not a solution. Second ordered pair is a solution. And the last one is not a solution. All right, that is our lesson for today. Let me know if you have any questions.